Yo, welcome back to another video. A little side note before I get into it. It is election day. So Donald Trump is our new president. It's crazy how fast that was announced. Honestly, I woke up and there it was. So that's chill. Shout out GitHub followers. We gotta make the Pokemon sound of the day. That Pokemon today is Vileplume. So let's take a listen, shall we? What the? His inflection at the end was a little weird, no? Vileplume. Vileplume. Okay. Let's get into the Leetcode of the day. Again, I'm going to try to do one Leetcode. Yesterday I was planning on doing more, but I came back from school and I just didn't want to do anything. Alright. What? What? Wait. You can only swap numbers that have set bits. Okay, got it. Okay, that makes sense, kind of. It's weird. It's a weird thing to do. This is a weird problem. This is a bitwise problem, obviously. I don't really know how do I get the set bits. How to get binary. Bin. That's not. Oh, I guess it is. Yeah. All right, so let's do a function def set bits num return let's just do bits len of str of wait no 4 hold on. Alright, so you'd be able to swap these. This is a weird problem. I don't really know where to go from here. Like, you're able to swap these, and we're able to swap these. I mean, I think the way I would do it is I would create like n arrays maybe. I gotta go to the bathroom, bro. Back from the bathroom. Okay. So, are there duplicates in the array? All right. Well, this isn't like about like doing it quickly. This is just about because I'm wondering if I can just do like selection sort. You know, where I kind of start from the back here. Maybe not the back. Well, if there's no function. Oh my god, already, bro. Sorted. This is backwards. Return true. If is sorted nums return true. Okay, now we have to do this part. We have to make the swaps. How do we do that though? That's the tricky part. Because my idea was like put them all in their own like set. Or something, I don't know. So like here's what I mean, right? I take, so let's copy the, can I just like copy this and put it in? Oh, oh boy. So I have this array, right? Basically, so we know that these have like a 1. Can we do a different color maybe? These have a 1 bit or like 1 set bit, and these have like 2 or whatever. What is it? 4. These have 4 set bits. Okay, so we're gonna take these right here. and we're going to split them up into their own arrays, right? Because like this is the one, yeah, I guess a dictionary maybe would work where the key is the set bit, and then the value is the array, right? So then we're gonna take this hash map, and then we're going to take the value, so the arrays, right? I'm talking about the arrays, and we're just gonna sort them. Okay. Right? And then after we do that, we're gonna go wait, no, this is gonna work actually, because what's gonna happen, guys, is we're gonna go in order, right? So we're gonna go on this array, we're gonna make a new one, right? We're gonna make this new array. Let's do orange. We're gonna go to this array. This arrow is kind of pointless. So this 8, we're gonna check its bit, right? So we know it's here. So we're gonna get the first, how do I explain this properly? Okay, so we're gonna run the function to get this 1 on this 8, right? Because we know this relation. This relation is calculatable. We're gonna take that and then look it up in our dictionary, right? So we're gonna, this 8 is a 1, so we're gonna look it up. And what we're gonna do is we're gonna look at the key, which is now, or the value, which is now sorted. We're gonna look at this key. Sorry, I had to blow my nose, but we're gonna look at this array, right? Because we got this 1, and after we look at it, we're gonna put in this spot the 2, okay? And after we do that, we're gonna delete it, okay? Boom, deleted. We're gonna move to this 4, right? Because we've handled the 8, so now we're gonna move to the 4. We're gonna get the 1 again, the bit 1. We're gonna look here that we deleted this. Now we're gonna take the first element in here, 4. So we're gonna put this here, right? Delete that. Look at 2 again. It goes to the 1. We're gonna look in the val. It's sorted. We're just gonna take the value, the first element, right? Because we're deleting these elements. So we're gonna take this first element. We're gonna put it here. Boom, 8. Okay. Now we're gonna go to this 30. We're gonna go to this 4, right? We're gonna look in the value, which is this. This is not the value anymore. I kind of, the drawing's a little bit weird. So we're gonna go to this 4, and then it's gonna go here. And using the same logic, we're gonna put a 15 here, the 15. This is deleted, 30. And then we're gonna run the isSorted function on this one, and it's gonna work out great for us. And I hope this doesn't TLE, because each delete function or operation is O of n. So I think this just ends up being n squared. But let's code it up, shall we? So let's just get a hashy going. Oh no, it's n squared log n, I think. Or it's n times n log n. Man, this is going to be tough. So this is going to be the bits or set bits, the value or the key, and then it's going to be sorted array as the key in the end. So for num in nums, it's got to be a faster way to do this, but it's all good. Probably way to do it like in place on some like magic shit, but basically if bits let's set bits, is that the name of the thing? If set underscore bits not in hashy, then hashy at spot set underscore bits, is equal to an empty array, right? And then we're just gonna do hashiet spot set bits dot append num. Okay, and after we do that, we're gonna loop through the keys in the hashy. So for key in hashy, hashiet spot key dot sort. Okay, let's just make sure that did what I think it did. This, I guess this can be set bits if it's more readable. Nice. Okay, so that's exactly what we wanted. Now we're gonna loop. This has got to be so convoluted. We're gonna have an empty array, and then for num in nums. We don't have to. Yeah. So again, we're gonna do this. So res dot, wait, hold on, delete first element of list Python. Okay. Does it like return? Maybe it should have been like a, no, I don't know. A dot pop 0. Yeah, this is what I would want to do right there. Dot append. I would do hashy at spot set underscore bits dot pop 0. Because then I delete it and I add the deleted thing to the element, and return is sorted res. Probably don't need this first part. But let's see if that works. It in fact did not work. Huh. Oh, it's empty. All right. Fuck. Wait, why is this expected false? You just swap these two and it stays the same. I don't get it. Did I misunderstand something? Any number of times, including 0. Oh my god, bro. I'm not gonna lie. I don't really get why this is not 75. 1, 2, 3, 4, right? Wait, so that's okay. 30. Dog. But it is sorted though. You swap 30 and 75 and it works. Can I only swap adjacent? Oh. Oh, I didn't read the problem. Dude. Yeah. So that didn't work. God dang it, dude. Oh, shoot. Yeah, that's embarrassing. Dude, I swear that happens more often than I like it to. Is this just bubble sort then? Like, but with an extra condition? Because then the way this would work, guys. Not what I meant. Oh, it's orange now. So kind of like we discussed, is that these would have the 1, and then these would have the 4, right? So then we would just start from the left to the right, okay? Like the way bubble sort would just works is that we would make swaps of these two, right? And then so it'd be like 4, 8. And then you would look at 8 and 2, okay? And then you would make the swap, because since 8 is larger than 2, you would move it to the right. And then you would look here. I mean, it doesn't. This works out because 8 is smaller than 30. Trying to think. Then you go from the left again, right? You start from this one. 4. You swap the 2 and the 4. So then it's 2, 4, 8. And then you keep 4 there because 4 is smaller than 8. And then you go to the 30. And then 2 is good. How do you start at the 30? I'm trying to remember. Oh, it's just a for loop. It's just a for. Yeah, okay. So let me just try to implement bubble sort by itself first. I've never implemented bubble sort on my own. So maybe I'll just do that. Maybe, is this, how would I even? Is it -1? Because then hold on. This is kind of tricky. start at 8. And then you go to yeah. Okay. So if, I think it is -1, by the way. So if nums at spot j is greater than nums at spot j plus 1, then you swap them. Is that it? That doesn't seem like it. 2, 4, 8, 15, 30. 2, 3, 4, 8, 16. Oh, that is right. Wow. Okay. Wow. Just implemented bubble sort from the get-go. It's actually kind of impressed, even though this is like not a hard algorithm at all. I really just applied what I learned in class to the code. Okay. So now we have this basic outline and bits at spot nums at spot j is equal to bits nums at spot j plus 1. Sorted nums. Now, that was really simple, and I overcomplicated it once more. I'm the god of that, though. I'm the go of overcomplicating it. Still under 30 minutes, though, after, like, completely being screwed. Okay, so why is it so slow? All right, let's watch the Leetcode video, and then we'll get into the project. How I built an unbeatable AI game, 15-year-old dev. Dude, I gotta turn this off, dude. The YouTube homepage is like actually... Trump campaign hasn't heard from Biden or Harris since projected 2024 victory. Breaking. U.S. election results. Donald Trump speaks after winning the 2024 presidential election. Isn't that so awesome?
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem, find if array can be sorted. The idea is relatively simple. We're given an array of positive integers, and we want to sort them. Well, I guess we want to determine if it can be sorted. If it can, we'll return true. Otherwise, we'll return false. But the criteria for sorting this is actually interesting. First of all, we need to know the number of set bits within each integer. For example, 8 looks like this in binary representation. And so, like, everything else is going to be 0. So the number of set bits within 8 is going to be 1. So let's just assume that we have the number of set bits for every integer in this problem, because that's not really where the complexity is going to come from. If we really wanted to, we could just get the count of bits for each integer, and we can do that in linear time, and then we can just store them in a hash map if that's all we care about, just being able to map a number to the number of set bits that it has. So I just quickly put the number of bits for each of these numbers. Now, they mentioned that the main operation that we can do is the swap, and we can only do it with 2 adjacent elements. So, for example, let's say these two, they're adjacent. We can swap them. But there's one more condition. They have to have the same number of set bits.
Well, I wonder what people said on the... Hold on, guys. Sorry, I'm getting distracted, but I love reading the discussion so much. What? Bro. Yeah, I agree with this. Let's take a look at this guy's profile. Me. This is so me. Think of bubble sort. Me. Hmm. No, it's not. Let me tell you why it's not, bro. Because sorting is not possible for it to be O of n. Let me tell you right now. I guess it is. I lied. Oh, this is all it is. Bit underscore count. Interesting.
Then are we allowed to swap the numbers? Okay, so we want to know if we can sort this or not. Just going by these rules, let's try a simulation. Let's try to sort it and see if it works. If we're only allowed to swap numbers, we can try to implement a sorting algorithm like this. Let's start at the beginning. We can compare 8 with the value to the right
This
of
is
it,
my
which
solution.
is 4. Now, 8 is definitely greater than 4, which is not what's supposed to happen. We want this to be sorted in ascending order. The smaller element should be over there. So clearly, we perform a swap here. But before you do that, you have to make sure that the two numbers have the same number of bits that are set. And this time they do. So we can perform that swap and we'll get 4 here and then 8 over here. And we'll do the same thing. We'll continue scanning from left to right, trying to put this guy in the right position. Well, it's definitely greater than 2. Let's swap these two and we'll get something like this. 8 will be over here. And then once again, we will compare it to the value to the right. Okay, 30 is greater than 8, so there's no need to do a swap here, but we can still continue iterating. And then by the time we get here, we get to the end, we look at these two elements and we say that, okay, well, 30 is definitely greater than 15. These should be swapped. Well, do they have the exact same number of set bits? Yep. So we swap these two, 15 and 30. The algorithm I'm implementing here, if you've noticed, well, I guess that was one pass through this. The second pass would be like this, where we start at the beginning and then we continue going up until the end of the array, except now we can actually skip the last element. Why is that? Because the algorithm I'm actually showing you right now, this dry run where we can only like swap adjacent pairs, is actually pretty much a sorting algorithm you might have heard of. It's called bubble sort. It's a pretty trivial sorting algorithm. It runs generally in n squared time in the worst case. But if the input array was already sorted, we could have actually gotten it down to be a linear time algorithm. But the reason it works like this is because if you notice, the main thing that we did with the first pass, like we started with 8 and we ended up shifting 8 all the way over here. We didn't continue shifting 8 because there was no need to. The elements here were already greater than 8. But we still kept going. Then we eventually got over here. We're at 30 and we swapped it with 15. So after we're done with all of that, the main guarantee with bubble sort is that, well, now the last element, at least this portion of the array, is definitely sorted. Because if there was an element that was bigger than 30, it would have ended up in this spot. We already went through all the elements. None of them were greater than 30, and now we know that for sure. And so the next thing the bubble sort algorithm will do is it'll find the second largest element among all of these, and that element will go over here, and it happens to be 15. And in this example, we can actually sort the array. I won't dry run through all of this, but eventually you will realize that the array can be sorted. If we ever got to a point where we wanted to perform a swap, but the number of set bits did not allow it, that would be a problem. For example, if 15 was instead a 14, I'm pretty sure that does not have 4 bits set. I think it has like 3 bits. Then we cannot swap these two elements, even though this one is bigger than this one. In that case, we would return false. So I'm not going to code this approach up from scratch, but I'll quickly walk you through the code of it. So I actually just copy and pasted this from like the editorial, but it's a pretty standard algorithm. So we have the length of the input. We create a copy of it. That's not actually required in this case. And then we have the outer loop.
I guess there's a better way to do it.
Starts from the beginning of the array. But the reason we have this n minus I minus 1, well, the minus 1 comes from the fact that we don't want j to be at the last index because we're doing j plus 1, and we don't want to be out of bounds. The minus I comes from the fact that we're skipping an increasing number of elements from the end of the array. And so we just do two things here. We first check if the elements are already in order. In which case we don't need to do anything, so we can just continue and get rid of this else, because I don't know why it's in an else, so I'll just get this out of there. This here, they're using a built-in function to count the number of ones in the binary representation of this number, and also the number at j plus 1. And so if they both have the same number of ones, we will just swap the elements. Otherwise, we'll return false. If we never return false, then we can return true out here. There's one small change you can make, a small optimization, I guess, which is basically, just to kind of get some space up here, we can create like a temporary variable, which I'll call my flag. I'll initially set it to false, and it'll basically tell us if a swap has occurred here. So if we perform a swap, let's set that flag to true, like this. And then if it's set to true after we're done with this entire loop, that means we performed a swap. But if we did not perform a swap, if flag is false, if not flag, well, then we did not perform a swap. What does that mean? Well, the only reason we wouldn't perform one is if the array is already sorted, so we can just return true from here, or we can break out of the outer loop and then return true down here. So I wonder if this code will actually work. It looks like it does pass, but there is a more optimal solution. Let's get into it. When you come back to the problem and actually think about it for a second, not just doing the brute force, but actually thinking about the problem, let's take a look at it. I have this portion of my array. Forgetting everything else, I know for sure, just by looking at it, that this itself can be sorted. Why is that? Because I have a block of continuous elements, and the fact that they're continuous is important because we're doing individual swaps on adjacent elements. So these are all continuous, and the fact that they have the same number of 1 bits set tells me that this forms a continuous block, or a sequence, or whatever you want to call it, subarray. It does not really matter what these numbers are, whether they're in order or they're not in order. It does not matter. As long as they have the same number of 1 bits set, we are good. This subarray is going to increase and increase and increase, and if these have 1 bit set as well, it's going to keep increasing. But what happens when we get here? If we're trying to create a sorted array, what should we do now? These do not have the same number of bits set. So if we needed to swap these, we would not be able to swap them.
True.
How do you know if you need to swap them? Well, it's not just about the element over here, actually.
The max element.
Because consider this, like instead of this being a 16, I'd rather make it a 32. I'm pretty sure that also has a single bit set, so this array can also be sorted into 2, 4, 32. But now when I get here to 30, well, this is bigger then an element in my first block. I already know this element cannot belong to this subarray, so we have to kind of perform a split. And by split, I mean that none of the elements here will ever be able to cross this line and vice versa. And the reason for that is the 1-bit count. Okay, so now that I have to create this line, I still want to know if I can sort the entire array. So then how do we do that? Well, consider this for a second. We're going to have potentially a big array. And let's say we already knew the split points, like there's a split here and a split there, whatever. The order of elements, like we know individually, this can be sorted. This can also be sorted. This can also be sorted, and this can also be sorted. Now we need to know, can the entire thing be sorted? Well, how would you know?
I think you just put like, I don't know why he drew 4 sections, but you can just do like a 2 right here and an 8 right here. You can ignore all the middle elements. Like you just get the min and the max. Maybe in like another array. So you put the way this array would look, it'd be 2, 8, 15, 30. Because the min and the max here is 15 min and 30 max. So then you just do that in order. I think I can just do it without even like watching the rest of this, but we'll just watch it.
That. I guess if I've sorted this, and let's say I have like 3 elements in there, and I sorted this, and I have 2 elements, what do I need to do to know that this entire thing can be sorted? Well, if the maximum element in the previous subarray is less than the minimum element in the current subarray, well then these 2 can be combined and can also be sorted. So this problem is just a matter of doing what I kind of just mentioned. Splitting up into like these subarrays, not literally splitting it, but just kind of keeping track of the split points. Like we'll know we reach a split point when we have different accounts like this. And so like suppose we're just going through this array, we go through this, we find the split point and there's no violation. Like this element is not bigger than this one. We won't even perform that comparison until we're done with the second group. So just to be very, very clear, let me show you exactly what's going to happen. We're going to go through, let's say, the first group. And I know the size is technically different than what I have above, but just bear with me. We'll go through this. Okay, this is sorted. Great. And then we get to this split. And that's when we will continue. Then we'll go through the second group. And then by the time we're done with the second group, now we actually have a real previous group to compare the current group with. When we were here, we actually didn't have a previous group. So for that, we'll have some default values. But here, what do we want to do? We want to compare the values. So for the previous group, we will maintain whatever the previous max was of that entire group. Of the current group, we will maintain the current minimum, but we'll also maintain the current max because we're going to eventually assign the current max to the previous max once we move over to the next group. That's the main idea behind this problem. Coding it up is actually easier than you would think.
No, I believe you, but maybe previous max. I mean, you just need to compare the previous max to the current min. So if this is true, then you continue where you compare where cur max. Cur max doesn't become the previous max, it becomes this one.
So let's just jump into that.
What? Okay, let me try coding it up without doing bubble sort, without cheating or whatever, brute force, stupid. I'm gonna keep this bits function though. It's cool. I like it. Shoot. Okay. So we got prev max equals float. This is just the default value, which is negative infinity. because no pre-max exists at the start. So for num in nums, if we'll just do cur bits equals bin. Is it guaranteed to have at least one in it? Yeah. Bin of nums at spot 0. Okay. Cur min equals this, and then equals infinity, and then cur max equals float negative infinity. Okay. If bits at spot num is equal to cur underscore bits, then and num cur underscore max equals max cur max and num. It's gonna keep going. It else, so that means the bits. So we got cur underscore bits equals bits at spot and num. Okay, that's the first thing. Oh, we have to find it though. Shoot. Oh, and you compare it from 2 away? Is that what you do? If prev underscore max is greater than cur underscore min, return false. Prev underscore max is equal to cur underscore max. Yes, that makes sense, I think. It's a little bit hard to read, but I need to put this down a line. And then you just keep going. Do I reset them too? I probably reset them, right? This isn't done, but I'm having a hard time visualizing how. Let me just make sure, like, oh, let me just print. 2, 4. Right, and we don't do these here. Do we just do one more check at the end? Why is it 15? It should be 30. Ah. Ah, okay. I see what I'm doing wrong. So here, the cur, we have to do this. We have to do this again. Okay, now the code's getting super messy. Okay, this is the optimal solution. This is like the most messy code ever. I could clean it up, but I don't want to, so I will not be doing that. Let's just see Leetcode solution. We can move on.
That. This will actually be the linear time solution,
Is this linear? Yeah, this is linear time as fuck.
by the way. And we won't need any extra data structures, I believe, so it should be constant space. Before we get started...
Is mine constant space? Oh my god. I believe mine is constant space as well. Probably don't even need this right here. Get rid of that. Just a nightmare function, dude.
Thing I want to mention is just how we're going to count the bits in each number. I'm just going to create a helper function for that. Let's call it count bits. It takes a number n, and if we want to do it like the old-fashioned way, we could do something like this, where we shift it to the right, and we have like a result, and we increment the result every time we see a 1-bit set like this, and then return the result. That will work. And this is actually one of the Leetcode easy questions, I think, in the Leetcode 150 list.
What the fuck? Res is n and 1. Dude, what?
List, but there's actually a built-in way to do this. Python has a function bin, whatever you want to call it, takes n, and then it'll return a string, I believe, which we can count the occurrences of 1 within that string, which will tell us the number of bits set. So very clean solution. So now we have that out of the way, we can get into the rest of the problem. I mentioned we're going to have a few variables, not too many, current min and current max. Initially, let's just set that to the first number in the array. We'll also have a previous max. We can't really set that to any element in the array, so we will set a really small value, -infinity, because every value is going to be technically be greater than that, so we will not have a violation, at least for the first group. And then we'll say for n in nums, we want to count the number of bits for n. So we can do something like this, count bits n. And we want to know, is this count the same as all the other elements in the current group? Not the values of the elements. Current min and current max are the elements themselves, but the number of ones in those is all going to technically be the same. So we can say something like this. If this is equal to the count of bits of current min or current max, it doesn't matter whether you do current min or max, because the count of bits should be the same. So if this is the same, then the group will increase. And we don't really have any pointers we're maintaining for the current group. So all we really need to do is update the current min and current max. Those can be updated like this. Current min is going to be the minimum of itself as well as the current number. Same thing with current max. Now, if this is not the case, then we'll do else. That means these two numbers have a different number of bits. That means we just reached a new subarray, a new streak. So what should we do? Well, what's the current minimum of the current group? That's this, current minimum. If the current minimum is less than the previous max, and the previous max was in a different group, and they have a different number of bits set, well, then we can't possibly swap these two elements, and thus we can never sort the array, so we should return false. If that's not the case, we can update the variables. The previous max will be set to the current max, and the current min and current max can also be updated. What we're saying is n is not a part of the previous group.
So you just give it to, and that's
why
why my solution is autistic.
So just like we did up here, we can set current min and current max to the first number within this group, which
that
is
makes sense.
just going to be n. So this is pretty much
Wow.
the entire solution.
That's so much more
if
clean.
we never return false, we can return true out here, but there's actually one edge case that I'm missing. What's going to happen with the last group? The last group is always going to have this equality set as true. Whether we have a group of size 1 or more than 1, we will never execute the else. So if I had a group that looked like this, 2, 2, 2, and then 1, 1, 1, this part is never going to execute, even though we know that this array can never be sorted. We're going to end up returning true. So the way to fix that is with the last group, check manually out here if the current minimum of the last group is less than the previous max, then return false. Otherwise, return true. And if you really want to be fancy, you can probably condense these, but that'll make it less readable. So if we're returning this, we would want to return the not of that, which will make that this. So not, and then that. And now we have a slightly less readable solution, in my opinion. But this one should also work. And after running it on the left, you can see that it does.
All right.
And this one is more efficient. If you found this helpful, check out Leetcode.io for a lot more. Thanks for watching, and I'll see you soon.
I found it really helpful. Drive it like you stole it. Awesome, bro. That's dope. All right. Let's get into the project, shall we? Been kind of... All right. Fix this from setting is playing to false when you play any song. Oh, I know how to do that. That's easy. Let me just get some music playing so I can get into the flow vibey state. You feel me, cuz? That's the thing. All right. Again, guys, if you're, I mean, I don't know if anyone's actually watching this part of the video. I think people only watch the Leetcode part. You guys will not be able to hear anything on the music player project because I have the sound muted and I don't want to get copyrighted. I'm pretty sure all of these songs are like, you can use them for free, but like you still get a copyright notice, I've noticed. So I'm just not going to mess with that. I don't like it. So. So we need to know where this function is called. But then I set it right here. I already do that. So it means it's working. This is not, I don't even need to fix this. This is fixed. I don't get it. What's broken? Reset was called and set is playing to false. Yeah, but then I can just do it like uh see? So it's fixed. This was never broken. I don't get it. Wait, so wait, what's broken then? Nothing's broken. I need to fix the print statements though. No, we don't need that. We don't need that. Right? Yeah, we don't need that. Um, reset was called. False. That's fun. Where is that being called? There we go. That's a problem. When I switch playlists, the man, this is just the way I coded it sucks. The problem is like when I switch playlists, like this is the one that's playing right now. Like you can't even tell. Dude, I think I just did this whole thing wrong. Oh, and that's broken too. Dude, there needs to be one song playing at all times, bro. See? I went about this all wrong. There needs to be one player. Like right now, the way I have it set up is that there is a player per song. Like these buttons and stuff, they correspond to each song. And that's the problem. There needs to be one of these only. I don't know why I thought it would be a good idea to have them set up like this, but that's just a terrible idea. But I don't really even know how to like do that. Like how would I refactor my code to fix that? I have an hour to do it. Okay, I gotta be able to do this in an hour. Okay, that's fine. Man, it's really not fine. Because the problem is that this playlist has an array of songs. I mean, that's fine though. Do I need like a main controller class maybe? Dude, this is not good, man. This is gonna solve all my problems though. Okay. Anyway, so what kind of variables, and what are they called? What are what is that? Fields. There you go. Member variables or fields. What kind of fields should this have? Because I'm trying to think, like the volume exists in here. So I don't need a volume field at all. Maybe public song current. I have to import the class. What? I didn't even know that. Current song. A queue. I might need a queue. Like private. Can I do? I don't think I can do this here, right? Okay. What's the problem, dog? Oh, private class. But if I did this, right? Put it here. That's not allowed, right? Yeah. Okay, maybe static. Shut up. I'll do what I want. I mean, it's gonna be like public. Maybe it's It's a private. I don't know. VBox layout. I would make this at the start of the program though. So like public main controller. I would have a dummy song. Yeah, so I need to make this a dummy song because there's no songs playing at the start. Um, how did I make it a dummy song? Dude, all right here. Yeah, I'm stealing that. Um, I need to implement this queue. I could just use the Java queue, guys, but I do want to implement the queue myself. Queue implementation in Java. I'm gonna quickly run through this. Maybe I'll watch a video on it. Let's see what kind of video we got. Learn queue data structure. That's maybe this guy. Bro code, he's chill. Yeah, but I want to implement it. Should I implement it or should I just use it? Oh, I need to use generics. Well, no, the queue's only going to have songs. It's not going to have. Did these guys call me an alien? Why am I an alien? Guys, why am I an alien? Why am I an alien, bro? Wait, this is part 13? Or is this like part 13 in linked list, stack, circular array, is empty, is full? Okay, I understand how a queue works, dog. All right, this is stupid, bro. I know what a queue is. Like, come on. It's seeming like I just shouldn't do it. All right, I'm just using the how to make whatever. I mean, the thing is, I have a project later that is like I have to do it all myself. And this is just the same page. So public q equals oh, I have to do it like that. So it's gonna be q song. There you go. So it's gonna be q equals new q song. What in the yeah, bro, I really just asked for that. Cannot what? Equals new I see. Using linked list. Does it need to be a linked list? It's seeming like it does. Okay. Okay. Um yeah, so basically guys, I don't really know what to do after. kind of like stuck mentally, mental block. Wait, why is it? Bro, what? Okay. Cause I'm struggling to figure out if I want to do the layout right now or if I want to do something else. Okay. Public get layout. Okay. Um yeah, I don't know. So it's like if and something needs to happen, and then it's like else, and then something needs to happen. Like I need to, do I make the buttons here? Dude, the problem is that the buttons, the way I have it set up, is like, dude, I have like a get button. Like, what the hell is this, dude? Oh, that's a song search. Like in here, I have all these. Maybe I should just be using song.getLayout. But then I feel like we run into the same problems we ran into before, where each song has its own set of controls. I don't know. And then in the main controller, I can just... Okay, that might actually be how it goes, dude. It's like label. Dog, what? And then it's like layout dot diff. Else. Hold on. Else, oh, I need the buttons, bro. Okay, I'll make fake buttons for now. Button. Okay, I think I know how to do this. Okay, next. Did I just set this up like such an idiot? Okay. So let's try that. And then wherever I do this, I should... Okay. Man, there's just no way to get... Like, yeah, like this should never happen. Get music controls. This should just never happen. But I'm gonna let it happen just for a little bit. Main controller equals new main controller. That didn't work. Layout with buttons. What buttons? Layout.getChildren.clear. Oh, I never added. Okay. Layout.getChildren.add empty. Okay, right. So basically, guys, I need a thing to add to the queue. So public, what is it, void? That's it. I don't even need this function because it's public. Public get public void, no, public vbox get songs in queue, but in a layout, in a, what the hell? So it's like for song queue. It shouldn't be S, dude. And then we have to, yeah. But this should be somewhere else though. This should be like, and every time you call this, it should update it. Can I just do that? I'm pretty sure I can just do that. I mean, it'll just be nothing though for now. Like it's here, but it's just not. This needs to be static in here. Why can't I do that? Make main controller return void. Wait, why can't I do that again? Oh, I never, whoops. Ah. There you go. There you go. Okay, now I can access that everywhere, which is fun. So here, play song. Is it here? Cur song. I don't know if this is gonna work, but wait, that's working, but where's the list? Huh. This should be updating get songs in queue. And should that low-key be in here then? I just don't know where else it would be. Music player app. I don't need this right here. Is it not adding it? Man, what the frick? No, it's not doing jack shit. Okay. That's weird though. Is this a different queue? I'm very confused. One. Oh, because I'm DQing it every time. Oh, I'm retarded. Good point. That is a good point. Q.remove. Yeah, that is what I'm doing. Okay. So when I'm on the playlist, hold on, I have an idea. I know how to fix this, guys. Don't you worry. I need to add another menu item. Yep. Okay. Menu item for adding song to queue. Does this need to be in here? No, I don't want to do that. But should we get songs in queue though? Like that's... There we go. So if it, oh, this next button doesn't do anything. Okay, I'll fix that right now. This is so messy though. P dot set on action E. Do I need like a current song or something? Like current song method? I'm just really struggling with this project. Like this is really tough. Cause like I need the next button to go to the next song. But the way I have it set up right now is it's like it's just always gonna do that. Wait, I guess I just do, hold on, do I just do q dot remove and then I call it again? And I like recursively? Is that what I do? What is all this? Oh, this is printing this. I don't need that. I don't need that. And that's the wrong thing. Oh. Previous? How do I even do previous? This is supposed to be next. Why did it go from 4 to 2? Maybe it's this. Yeah, that makes sense. God dang it, bro. Guys, I feel like getting distracted right now. I gotta check if this still works. It does still work. Okay. Q.remove. Why doesn't this not work? Okay, dude, I just need this next button to work. That's my goal. In the next 10 minutes, I gotta make the next button work. Okay, how do I make the next button work? Why is this not working? What should happen is that the current song is removed. So it's song cur equals cur dot reset, and then that's that right there. Okay, Q is 4. Now it's 2. Bro. What? And it only shows 1. Okay, you know what I need to do? I need to stop adding the same song. So I'm going to add 1, 2, 3. I'm confused, dog. Okay. One. Wait. I think I know the problem. I think the problem is the way I'm handling, like, clicking on a thing. Because I need to click it. I'm going to do 1, 2, 3. So the next, it should be nightfall. Is that nightfall? I don't think it is. God, freaking stupid. I don't get it. I don't get what's going on. But it didn't reset the right song. Do I just need to reset it? Is that all I need to do? Is this a useless step? Q dot, is it just like peak or something? There we go. Reset may, okay, it won't do that, bro, trust. Okay, it works, I think. But I think I need to add a label here. Yeah, it definitely works, dude. Okay. Current song. And then I'm going to do current song. I'm gonna make a new label. Current song equals new label. Right. All right. Let's try now. So when I click this next, this should stay the same. When I click, there we go. Okay. This should probably be down here. And then it should just play it immediately. So we can just add that real quick, probably. Okay. All right, that's gonna be all for me today. I think that was pretty good progress, honestly. I think the thing I just fixed is gonna make it way better. All right. Peace.